Okay, boys and girls, we got a couple word problems today. We're a little short on time today. You got 33-minute classes. This might be the last of your days off of school due for weather purposes, so hopefully you enjoyed your time yesterday. Yeah, I know we're supposed to have a cold snap. I hope it's not that cold, because I'll be honest, I don't know if I can handle being away from you guys anymore. I get lonely. It's... I know, but I try to turn on your videos, and, I'm like, maybe I should creep Larry's Facebook page. And I'm like, well, that's kind of, All right. It says, boys and girls, find the equation for the line tangent to the curve 2x minus 6x squared minus x to the third that has the largest slope. What is the phrase that is driving this problem? Largest slope. Okay. Whoop. All right. Okay, so this is really important, okay? I'm going to talk to you about this problem in two different ways. Number one, I'm going to look at the picture. Okay, 2x minus 6x squared minus x to the third. What kind of shape is that? Yeah, exactly. Okay? Something like that, okay? Now, you tell me when you think I'm at the spot where the slope is the greatest. It's a good question. Greatest doesn't mean largest in terms of absolute value. It means simply the most positive value. So right now, is the slope positive or negative? How about here? So it's got to be somewhere between here and here, right? In fact, you're absolutely correct. It does occur at the point of inflection. Okay? Okay? So, one thing to do is to look at the graph. Another thing to do is to look at the phrase. Largest slope. When you say largest, we haven't used that word yet. We've used a different word before. Yeah, maximize. So we want to maximize the slope. So I just want you again to connect these pieces together. What do you do to maximize something? What do you have to take in order to maximize something? You have to take the derivative, right? The derivative of the slope. How do you find the slope? Take the derivative. So when it says the largest slope, it's asking for the derivative of the derivative. So which derivative? The second derivative. Okay? The second derivative is what will solve this problem. And you notice the point of inflection, we find that by setting the second derivative equal to 0. See how it all connects together? So, we have f of x, and this is going to be really important, everybody, that you keep track of these, is 2x minus 6x squared minus x to the third. The slope is going to be f prime of x is equal to 2 minus 12x minus 3x squared. And in order to maximize the slope, the f double prime, which is so we will be able to maximize the slope. Oops, sorry. So if we take this and set this equal to 0, I get 6x is equal to negative 12. So what does that mean? Okay, very good. At negative 2, so this x coordinate right here, the x-coordinate is -2. To find what? The y. But let's hold on. Our goal here is to write the equation for the line, correct? So the equation for the line requires a point on the line, and it also requires slope. So let's do the point on the line first. The x value is -2. In order to find the y value, I plug it into the first one. So 2 times -2 is -4. -2 squared is 4 times 6, so 24. And then -2/3 is -8, so plus 8. -20. Now, how do I find the slope? First derivative. Exactly. The first derivative tells us the slope. So I plug in -2 to the first derivative. So notice you're having to plug it in a couple different places here. So if you plug in -2, you get 2 plus 24 minus 12. 14? So let's solve. We'll do the Elizabeth way. Just sure. So much more easier. We need a quote board in here is what we need. Any questions? Okay. We will get through this problem, but we will not get through the next one. The next one takes quite some time. These next two problems are challenging. I will tell you that over the course of the previous 2 years as I have taught this course, I get a lot of anger and frustration from students about these two problems, okay? Yes, exactly, yes. This gnashing of teeth syndrome that I get where people are like, "Argh." Okay, but here's what I did 2 years ago. I had a lot of complaining about this, and they were a very sharp class, and one of my favorite classes I've ever had. But they were complaining about these problems incessantly, and so I just put it to them. I said, "Here's the deal: they're on the test. Period." Because and the only reason I did that because I was so mad about all the complaining. I just said, they're on the test. You're going to figure them out. And they were like, the world had ended. I mean, it was like, what? I said, you know what? If you can't do them, that's the measure of how good you are at math. That's all there is to it. And they were like, I used to like him, and I don't anymore. And so around we went. Here's the deal. You will be able to do these problems. It will just take some time and practice, okay? So the first time you see it, you might walk away like, whoa, okay? But trust me, you'll be able to work these through, okay? So find the equation for a line through the point 4, 2 that cuts off a triangle from the first quadrant with the largest area. Ooh, boy. What do you want to do first? Okay, draw the picture. All right. I'm going to have some extra space here, so let's draw the picture. excellent job. You guys said, plot the point. So the first thing, we always start by modeling the problem. So I plotted it. Now what? Draw a line. We'll draw the line. Okay, so you know that the slope is negative. Okay? You had a question or thought. It was good. Say it. Because it has to make a triangle. And if you ended up with a positive slope, it wouldn't be able to fully cut off a triangle from the quadrant. So that's why we know the slope is negative. Excellent point, because when we solve this problem, we're going to come up with a positive and a negative solution. You do know it's negative, okay? So, what shape do I have? I have a triangle. So, what do you want to do now? What phrase drives this problem? Largest area drives this problem. So therefore I should write down area equals 1/2 base times height. Very good. Okay? Now, if we take this line and we kind of move it back and forth, so to speak, okay, you're going to see that the x-intercept changes. You're going to see that the y-intercept changes, right? Okay? So, that's somewhat of an issue here, all right? Okay? What I'm going to call this is, we'll say that this is, in fact, right here, that is the base. And to keep our language straight, I'm going to call the x-intercept b for the length of the base. Okay, so what now? Good, so we have that h for height, so this length right here is going to be h. What's that? I've practiced a lot. Yep. Yes. I will admit, I too used to struggle at making brackets. Then I'll tell you the key. And I discovered the key. I started to practice drawing seagulls. And when I was good at drawing seagulls, I became better at drawing brackets. Okay. Okay, watch. If we want to write the equation for this line, boys and girls, if we want to write this equation for the line, what do we have to know? We have to know the slope. We don't know it, do we? All we know is it passes through this point. So, true or false? The slope of the line, will help determine the area of that triangle. It sure will. And so what we need to do is we need to write a function of the slope. Okay, so we need to really focus on that slope piece. So I'm going to come up with two equations here, okay? And one I'm going to set for h, and one I'm going to set for b, okay? And so this is a trick. So remember, in the 4 boxes, which is the most difficult box to figure out? Second box. So this is the second box piece, and this is kind of challenging to think about. But if I'm going to write an equation for a line, and I want to maximize the area, well then I need to have a variable of m, don't I? I want area. Here's what I truly want. I want area in terms of m. That's my goal. Because as the slope changes, the area will change. And once I find that slope value, then I can write my equation for my line. So that's really what I want. And if I want to write something in terms of m, then that means I got to use Elizabeth's formula. Y minus y1 is equal to m times x minus x1. You are so inappropriate. Okay, so let's look at this, okay? Let's plug in our values here, okay? what we have is, we know what y1 and x1 are, right? Now, also, does h refer to the y-intercept or the x-intercept? The y-intercept. And when you have a y-intercept, the x value is equal to 0. So you know that x is 0. You know x sub 1 is 4. And you know y sub 1 is 2. Okay? Exactly. So y will then be h. The y-intercept, so the y value h happens when x is 0. So I have negative 2 equals m times 0 minus 4. Or negative 2 is equal to negative 4m. Oh, I'm sorry, h minus 2. Sorry. So, h is equal to negative 4m minus 2, or plus 2. So this is what I have right here. Look at this h value. I have a representation for the height in terms of the slope. Negative 4m plus 2. How cool is that? Got it. All right, so we're going to do the same thing here. B refers to the base, the x-intercept, and the x-intercept occurs when y is equal to, so you know this value is 0, and we know that x is going to be b. So that's the x-intercept. What do you know is y1? Still 2, and x sub 1 is 4. So if we plug this in, we get negative 2 equals m times b minus 4. And what am I trying to solve for? Very good. Trying to solve for b. So if I divide both sides by m, negative 2 over m is equal to b minus 4. Add 4. So 4 minus 2 over m is equal to b. Yeah, what do we do? Yeah, we plug it back in the area formula. Area in terms of m is equal to 1/2. What's the expression for the base? 4 minus 2 over m times, what's the expression for the height? Negative 4m plus 2. That's my function. We want to maximize the area, so we want to maximize that function. Take the derivative, set equal to 0. So, before we take the derivative, what should we do? Okay, let's simplify it out. Area in terms of m is equal to 1/2 times 4 times 4, or 4 times negative 4m, negative 16m, 4 times 2, 8, negative 2 over m times negative 4m, 8. And I know. And negative 2 over negative 2 over m times 2 is minus 4 over m. Very good. Yep. Very good. And we're going to talk about that today in Algebra 1. Okay, so negative 16m times 1/2. Negative m, yep. 8 plus 8 times 1/2 plus 8 minus 2 over m. Alright, so I have my function. Now what do I got to do? Take the derivative. So we got negative 8, and then negative 2 over m. That's like it's like negative 2 to the m minus 1. Very good. So it'll be positive 2 over m squared when you work that out. You take that derivative. Now I take instead of equal to? Why? Because we're maximizing, and local maxes and mins occur when the derivative is equal to 0. See how beautiful it all is? 0 equals negative 8 plus 2 over m squared. How to solve? How to solve? Add the 8, cross multiply. 8 over 1 equals 2 over m squared. 8m squared. Divided by 8, m squared equals 1/4 square root. M equals plus or minus. Is it the positive value or the negative value? It is the negative value because it's cutting off in the first quadrant. So therefore, we know that the slope, is negative 1/2. Can you now write the equation for that line? Yes. Y equals negative 1fx plus 4. Okay. Wasn't that awesome? Okay, so we're almost out of time here. We got 15 seconds. I'm going to give you 2 problems, just like we did. You're going to have one where you're cutting off a section and one where you're maximizing slope. Tomorrow we will do the famous gutter problem. .7, page 285. Yep. Whoa! Hey, you guys, one small issue. We did everything right with that first problem, okay? You want to do 44 and 46 out, but, or with that last problem. But, technically, I never go back and make this change. We're not trying to maximize the area. Technically, you are minimizing it. If you think about it, if we drew the shape again, well, just think about it. You know, the more of a slant you draw it at, what's going to happen to the area? It's going to get bigger. So actually, we just minimized it. So I'm sorry, the problem says minimize. Same type of problem. We minimized it. We didn't maximize it. My fault. Just language. So you're good. 44 or 46. No snow day tomorrow.